Welcome to the Hiscall Technology Podcast, where we are communicating tomorrow's business needs today. From just outside Nashville, Tennessee, join Hiscall as we discuss all things telephony, data, and infrastructure related to business leaders. Here we go.
Did someone say work? No, that's a bad word. When it's sunny and 75, how does anyone get anything done when all you want to do is let it unwind? With a cooler, some water, clear blue skies. Yeah, man, that sounds just right. So grab a little sunshine, get a tan while you can. Forget about your plans, cause the summer won't last forever. So just sip, sip, sip away before it slips away. Yeah, just keep sipping away. This is Chuck, bringing you another episode of the Hiscall Technology Podcast, recorded from Studio C at Hiscall Incorporated, located just outside Nashville, Tennessee, Music City, USA. I'm grateful for you listening to the podcast today. No matter if this is your first time or you're a regular listener, we appreciate you taking the time to download the podcast and spend this time with us. So how did Nashville get this nickname, the Music City? You might think it came from some record executive, recording artist, or something like that, but the name comes from a very unlikely source. Queen Victoria is most often credited with the nickname. The story is, Queen Victoria once heard the world-renowned Fisk Jubilee singers from Nashville's Fisk University, and she was so impressed with their performance, she declared they must have come from the Music City. Now, whether or not Queen Victoria actually said this, the name stuck. By the 1950s, Nashville was known the world over as Music City, USA. So there you go, a little trivia with the tech on today's episode. Working in and around the Music City, I've had the opportunity to work in some recording studios and other enterprises important to the music industry. My job has provided the opportunity to see some really neat working environments and meet interesting and occasionally famous people. After a meeting once at the Country Music Association's headquarters, I walked out the door and I ran into the chart-topping trio Rascal Flatts. These guys are super famous and hugely successful with something like 14 number one hit singles. The lyrics I read at the beginning of this podcast are from a song by Rascal Flatts called Sip Away. Recently, I read a post on LinkedIn that said, "Sip is the future." I don't necessarily disagree with this statement, but I think it's more accurate to say, sip is now. On this episode, we're talking about Session Initiation Protocol, SIP. This is not exactly what Rascal Flatts had in mind when they recorded that song, Sip Away, but it makes a fun introduction to the podcast, and as we wrap up, you may just decide you need to sip, sip, sip away. In the course of 20 plus years in the industry, I've seen a lot of changes. I came into the industry about the time ISDN PRI was moving outdated landline technology to digital. In those early days, I spent some really long nights on a few ISDN PRI cutovers. There would be protocol mismatches. It just took a long time getting everything synced up in those early days. I also mentioned working at some recording studios around town. Those recording studios are the only places I ran into ISDN BRI circuits. They were popular for connecting from the studio to radio stations and other environments that required high-quality audio and video. I even installed a few Lucent Technologies 8510T ISDN BRI voice terminals. ISDN changed the way companies communicated, bringing flexibility for data, video, and voice communications. As with most technologies, there is a life cycle, and ISDN has reached the end of its lifespan. Now, the actual end date remains a bit unclear. We've been hearing rumors for years that ISDN is going away, but that date seems to get changed and pushed out year by year. But it's imminent. It's happening. So while ISDN brought great benefits, IP telephony came along. changed the industry. TDM technologies used by ISDN on legacy telephone networks and digital desk phones was replaced by voice over IP networks. IP telephony largely adopted the H.323 protocol as the standard to deliver a traditional feature-rich user experience like that on traditional digital telephones. As time moved along, users and the enterprise required new ways of communicating. H.323 was limited to voice and video. It was not capable of extending to the multimedia requirements of the ever-changing enterprise. The development of the Session Initiation Protocol, SIP, addressed these limitations and brought a level of standardization to voice over IP. In addition to voice and video, SIP can support many other types of media. We're going to cover Session Initiation Protocol, SIP, on this episode. My goal is to provide a high-level overview and cover why it's important. Learning the value and operation of SIP is important for all of us working with and in communications. The SIP standard is defined by the Internet Engineering Task Force, Request for Comment or RFC 3261, and updated in RFC 6878. SIP is a signaling protocol that supports session signaling and session control. It's used to establish, modify, and tear down communication sessions in an IP network. These communication sessions can be as simple as a two-way phone call or as involved as a multi-party web conference with audio, video, text messaging, and even a shared whiteboard application. SIP is built on other familiar protocols, namely the same hypertext transfer protocol, or HTTP, we use to get around on the internet. SIP contains many of the basic principles of HTTP. SIP is a text-based protocol, making it easier to read. This helps us understand what is going on in the communication sessions when we need to troubleshoot or we need to extend a session. Since it is reliant upon other protocols and is easier to understand, new features can also be added to SIP without the need to modify existing SIP entities in the call path. It's important to remember SIP is a signaling protocol based on establishing and managing SIP sessions. It doesn't care much about the media used for the sessions. Actually, another protocol, the Session Description Protocol, or SDP, defines the media carried over the SIP session. SDP allows SIP to establish a session independent of the underlying media stream. Unlike H.323's limitations to voice and video, SIP can be used to establish sessions of most any type. As communications have evolved beyond the simple two-way voice call, SIP supports the other ways we want to communicate today, including multi-party voice, video, instant messaging, and SMS text messages. I like to think of SIP as a polite signaling protocol. SIP messaging is a series of requests and response messages. And if you think about it, practically all communications begins with signaling. Let's say Bruce and I work in an open office area. If I want to talk to Bruce, I signal my intent by calling over, "Hey, Bruce." Bruce recognizes the invitation to talk and signals back to accept. "Yeah, what's up?" Now that my invitation signal has been answered with Bruce's acceptance signal, we're ready to converse. We begin our dialogue. When we complete the conversation, I issue another signal, bye, this time to end the session. Bruce signals back, "Okay, catch you later." SIP follows a very similar type structure, albeit digitally. A SIP phone, for example, sends a request to another SIP phone to set up a call between the two devices. The other SIP phone responds to the request that it is available and ready for the call. The SIP phones exchange preferences or capabilities using the Session Description Protocol I mentioned regarding the types of media, codecs, etc. that each can communicate. The call is set up And the media for the phone call uses the real-time protocol, RTP, to establish the audio stream. RTP is the same protocol we've been using for years with H323. With its flexibility to set up, modify, and tear down sessions, SIP's popularity has grown throughout enterprise communications. We see it used for application integrations, smarter desk phones, and connectivity to the public switched telephone network, PSTN. SIP provides a great building block for application development to meet growing business requirements. SIP can allow first and third party call control, which simply means that applications can be written that direct endpoints to make a call, answer a call, or release a call. Now, you may say, Chuck, we don't need SIP to do that. And that's true. Computer telephony integration has been able to provide call control using application programming interfaces, but that's fairly complex, and it's been focused on the endpoint. With traditional CTI, the applications control and monitor the endpoint regardless of who might be using the device. In this device-centric model, each device is treated as a separate entity with no special connection to its owner. The problem is an enterprise user might utilize multiple devices throughout the workday. Take me, for example. It's very common for me to use an office phone, a soft phone, and a mobile device as I go throughout my workday. A user-centric model is needed to keep up with the user no matter the device. With SIP, a single application can manage all my devices while providing present status generated by those devices. Traditional CTI also keeps the data and processing separate from the actual telephone call, and this API is required to synchronize the data with users, applications, and endpoints. SIP, however, is capable of including the data within the SIP messages, and the data remains with the call flow as it is passed between users, systems, and applications. This is great since all the call data is available wherever the call ends up. Traditionally, phone system manufacturers have developed their own proprietary protocols for use with their phones. You could not take a phone from one manufacturer and get it to work on another vendor's phone system. For example, you could not take a Nortel phone and just connect it to an Avaya system. With session initiation protocol and the introduction of SIP phones, third-party IP phone vendors have introduced desk phones that will work on many IP phone systems. We have even recently seen Avaya open up their SIP endpoints to work on other cloud-based provider systems. SIP phones themselves are more intelligent than traditional digital and IP endpoints that relied upon the call control server for their instructions. Traditional telephony is hardware focused. The telephone is connected from the phone back to the central controller by dedicated wires. The call controller manages the process of connecting the calling and called parties. A SIP endpoint is an intelligent endpoint that can function without the assistance of a PBX. I think about the Avaya 1X Quick Edition back about 2006 or so. This was actually my first exposure to SIP endpoints. This little system consisted only of the 1X Quick Edition endpoints and the PSTN gateways. There was no central controller. It was really a slick little system, but I don't mean to get off on a tangent. Even with these intelligent endpoints, you can't always assume that SIP phones are equal. We have found there may be limitations of features and function when third-party SIP phones are deployed. The IP phone system manufacturers still develop their SIP phones with unique features on their phone systems. And we generally recommend phone devices developed for the systems we sell, with the common exception being conference phones. CompTel and Poly make some really great SIP conference phones and provide interoperability documentation for most systems. In addition to the third-party SIP phones, these mobile devices we all carry around have become enterprise communications devices. No doubt about it. The explosion of work from home this past year has only compounded mobile device usage for enterprise communications. I am constantly talking with customers about how to integrate their mobile devices into their call flows. SIP has allowed the phone vendors to provide mobile phone apps that securely integrate into your communications network. As many of us begin returning to the office on a part-time basis, many may find they never return to the office full-time. You may continue working a hybrid environment with an office at your company and a virtual office at your house. It may be with more people out of the office, you have to cover more area and have a couple of places you work depending on the time of day or the day of the week. In any of these scenarios, it could be helpful to have your number readily available at any of these work locations. SIP offers multiple device access. Some SIP servers support single registration, which means only one device can be registered with the SIP service per SIP account. Other SIP servers support multiple registrations, which means more than one device can be simultaneously registered with the SIP server using the same account and able to receive calls on all the registered devices. This means you can be registered to multiple desk phones, a soft phone, and a mobile application all at the same time. We have talked about SIP applications and SIP endpoints. Let's discuss SIP trunks. It seems we're always considering ways to reduce the IT budget. One of the places we've been looking for many years to reduce cost is replacing those old T1 and ISD and PRI connections with SIP trunks. Traditional telephony utilizes dedicated lines or circuits. It's hardware focused. These dedicated lines could be analog POTS lines or T1, ISD, and PRIs. A SIP trunk is an alternative to the traditional PSTN T1 and ISDN PRI connection. As an IP protocol, SIP runs on the same network as data traffic. Since enterprises already have some form of IP network, it makes good sense to use the IP network to connect to the PSTN. This convergence of voice and data means a SIP is a logical entity and really has more to do with bandwidth than hardware or physical wires and circuits. We often find SIP trunking provides enough savings to offset the cost of the change. Lower pricing is sometimes the result of competition. Competition often breeds lower pricing. British economist Sir John Vickers is quoted saying, "Competition is good for consumers for the simple reason that it compels producers to offer better deals, lower prices, better quality, new products, and more choice." With SIP trunking, you're no longer limited to the traditional voice service providers. SIP trunking offers many other provider choices, thus creating significant competition. This competition allows you, the consumer, to obtain more favorable agreements at lower prices and also provides far more leverage when dealing with your incumbent carriers, forcing them to price services lower with hopes of retaining your business. In addition to the lower costs compared to T1 PRI trunks, other reasons for moving to SIP include more flexible service, on-net or SIP-to-SIP calling, and flexible business continuity. The legacy T1 and ISDN PRIs that brought so many benefits over the years really are not that flexible. Each T1 and ISDN PRI circuit supports a limited number of channels. When you need more than the maximum channels supported on the circuit, you have to add capacity with another circuit. For example, let's say you have one ISDN PRI connection with the maximum 23 channels. Let's say the business grows and you require more connections, but not a full 23 channels. Maybe you only need capacity of 10 more channels for a total of 33 channels. This requires two ISDN PRI connections, which provides considerably more capacity than the number of channels actually needed to accommodate the traffic loads. SIP's provisioning flexibility allows an enterprise to implement just what is required and avoid over-provisioning. Or maybe your business has seasonal or other variable communications requirements. For instance, it could be your business only requires those 33 channels we discussed during the 3 or 4 months for the Christmas holiday season or other times with spikes in call volumes. With SIP, the number of concurrent sessions or channels can be rapidly expanded or reduced. This is sometimes referred to as bursting, whereby capacity is increased and decreased without having to add and delete trunks and avoid paying the associated costs to the carriers. Another feature with SIP trunks we've had many customers take advantage is virtual telephone numbers. A virtual telephone number, or VTN, is not tied to a specific phone line. Remember, with legacy voice services, it's hardware focused. A phone number is provisioned to work over a single phone circuit, and that circuit is physically connected by telephone lines from the phone company to the destination address. Could be a home or a business office. All calls to that number can only be sent to that specific destination, and the phone system at the business office routes the call based on the programming. A virtual number eliminates the physical requirements and limitations associated with the legacy voice services. With VTNs, the number is no longer tied to the physical lines, giving you more control and flexibility in how calls are received. Where we have seen the greatest use of virtual telephone numbers are businesses that want a local number in an area, but they don't have a physical presence. We've also seen customers utilize VTNs to centralize call answering for remote locations. For example, a company with remote branch locations wants the local number answered at the headquarters site by the call center or customer service group. The cost of these calls is kept low as they're considered on net. When we consider deploying SIP trunks, there are several ways of terminating the SIP trunks to your communication system. Your IP PBX can communicate directly with the SIP trunk provider's network. But if you have a legacy TDM PBX, you will need a gateway to handle communications with the PBX and SIP trunk provider. Either way, a session border controller should be considered for your SIP trunk deployment. It's important to learn more about the SBC before deploying, and we're going to cover the SBC in more detail in a future episode. But the SBC provides security from malicious intrusions as well as other important services, including normalization and monitoring of your SIP trunk services. As I mentioned, session initiation protocol is a defined standard, but the definition leaves room for developer interpretation. As a result, the early days of connecting SIP trunks varied based upon the IP PBX vendor's specific version. The SIP trunk provider had to configure their interface to satisfy each of the IP system vendors. As you might imagine, this created some challenges during implementations, and the service providers, they just didn't want to keep up with all these various system versions. The industry needed a more common SIP trunk interface. The SIP forum created SIP Connect, which you can think of as an agreed upon interpretation of the SIP trunk standard that vendors and providers voluntarily adopt. According to the SIP forum, the SIP Connect technical recommendation is an industry-wide standards-based approach to direct IP peering between SIP-enabled IP PBXs and VoIP service provider networks. When selecting a SIP trunk provider, it's a good idea to check if your SIP trunk provider, IP phone system, and SBC vendor follows the SIP Connect recommendations. There are multiple versions of the SIP Connect recommendations. At the time of recording the podcast, SIP Connect 2.0 is current, but there's also SIP Connect 1.0 and 1.1. SIP trunking may not be a cost reduction solution for every organization, but it will be for most. Here's where it's helpful to have a partner that knows your options for SIP trunks and can provide recommendations that follow SIP Connect for interoperability and manufacturer-supported configurations should you encounter any problems. SIP has been a game changer in business communications, impacting everything from application integrations, user endpoints, and SIP trunks. So we will wrap up this episode of the podcast. Thank you for listening today. Your time is valuable, and it means a lot to me that you will spend a little bit of it with us. If you find the material helpful, it would mean so much to me if you would subscribe to the podcast, like this episode, and leave us an encouraging and positive comment. Your feedback helps others find the podcast. Hey, if nothing else, take the old-fashioned route and tell somebody about the podcast over a cup of coffee. Now, allow me to circle back to our opening song, Sip Away. As I record this podcast, summer will be here before you know it. Make the most of it. As the song says, it won't last forever. Don't let it slip away. And don't be afraid, only believe.
Thanks for taking the time to listen to the Hiscall Technology Podcast. Subscribe to this podcast so you can stay up to date with today's business communication trends. To learn more about Hiscall solutions for your business needs or to listen to previous podcasts, visit us at our website, hiscall.com.